Hello everyone, welcome back to Xcoding with Alvian. In this video, we are going to experiment with building Trello UI clone using SwiftUI drag and drop API. Trello is an app used for task management, where the user can create board, add lists, and cards. It can be used to create a Kanban board to visualize the pipework at various stages of a process. Let me show you the demo of the Trello clone that we will build on this tutorial. Here, I have the app runs on an iPad Pro 12.9-inch simulator. This is the main board view containing all the lists inside a scroll view with horizontal axis. To add a new list, I can just tap on this Add List button, input the text, and press Save. The list is added. I can just drag it and move it around. And let's say I want to move a card to another list. I can just drag it here and drop it into another board list. I can also reorder the cards inside the board list by dragging it and moving it around. I just want to move this to in progress, move this to key A, and we can also rename the board here using this rename button inside the navigation bar. And you can also delete a board, rename the board. Let's say I want to delete it. Here we have also this menu button to edit the card content, error handling, backend. Okay, it got updated. And let's say I want to remove it, just click on the menu and click delete. Okay, that's all the. Oh, before that, I can also add card here, the backlog. Let's say iOS. Okay, the card got added to the board list. That's all the main features of the app that we'll build on this tutorial. Before we begin, let me outline all the topics we are going to learn in this tutorial. First, using class reference type for models and conform to observable object protocol. Second, add custom uniform type identifier to the models and conform to the NSItemProvider Protocols for supporting drag and drop. Third, using state object and observable object to observe changes in models and update the views in hierarchy. Fourth, learn how to use drag and drop API for lists using onInsert and onMove modifiers. Next, learn how to use onDrag and onDrop modifiers for SwiftUI view. Next, learn to use and implement drop delegate on SwiftUI for more granular control of drop action lifecycle. And next, learn to use Introspect Swift package to enable UIKit API access on SwiftUI list and scroll view. And finally, persisting the board data to disk. That's all for the topics we'll learn. Make sure you have installed Xcode 13 as the minimum Xcode version, as we are going to use iOS 15 SDK. You can also download the completed project from the Github Repo story that I have provided at the description if you encounter any issues. Now, let's begin and open Xcode. Let's begin by creating a new Xcode project. Select New Project, and then make sure to select iOS here and select App. Click Next. For the product name, give it a name of Trello Clone. Provide your own organization identifier. Make sure to select SwiftUI and just uncheck Use Core Data and include tests. Finally, click Next. Save it to any location that you want in your computer. Now let me set this as full screen. So for the first task, let's create all the models first. We will create three models: board, board list, and card. In the project navigator, let's create a new folder here, give it a name of models, and then expand this models folder and create a new Swift file, give it a name of card. So now let's declare a class named card and make it conform to the observable object and identifiable protocols. For this card, we will have three properties. Let's begin by declaring the first one by using private set var and name it as ID, as we are conforming to the identifiable. So we need to declare an ID property. For the type, it will be UUID. Let's just initialize it and assign it as the default value. And then for the second parameter, we need to have a reference to the related board list. So instead of referencing the actual board list object, we are going to use the ID of the board list. So declare a var given a name of board list ID with a type of UUID. And for the third property, we are going to declare the content of this card with a type of string. For this content, we are going to add a published property wrapper. By using published property wrapper in observable object, SwiftUI view can have a reference to this observable object using either state object or observe object property wrapper, and then have a reference to this content inside the view, for example, inside a text. So whenever this content got updated, the view will be updated. It will be redrawn when using this publish property. Okay, so because we are using class as the type, the compiler does not automatically synthesize the initializer for us as when we are using struct. So we need to create our own initializer. So create an initializer init and with the parameter of content with the type of string and board list ID with type of UUID. Okay, now let's assign the parameter to the associated properties, content and board list ID. Okay, let's try to build. Okay, the build succeeded. Now we have the initializer and all the properties. Let's move on to the next model with a new Swift file. Give it a name of board list. Okay, so let's declare a class named board list and make it conform to the observable object and identifiable protocols. And we also have the ID with the private stat access and type of UUID. Let's also initialize an UUID and assign it as the default value. For the second property, this board list itself will have a reference to a board. So let's declare a var named board ID with a type of UUID. And next, we are going to have two published property, two properties with published property wrapper. The first one is the name of the board list with the type of string. And the second one is cards. So basically, this board list will have an array of cards. Okay, it also needs an initializer. So let's declare it. For the parameter, we have name with a type of string, and then cards. It's an array of card. Let's set the default value as empty array. And we also have the board ID with the type of UID. Let's assign the name with the name parameter, the cards, and finally the board ID. Let's try to build. Okay, the build succeeded. Next, let's create a class for the board. Inside the models folder, create a new Swift file, give it a name of board, and let's declare a class board. Make it conform to observable object as well as identifiable protocols. We also have private set var ID with type of UUID. And for the second property, we have a published var name with type of string. This is the name of the board that will be shown inside the navigation bar. And next we have the publish var lists. This will be the board list array, an array containing the board list. Okay, this will be shown inside the scroll view with the horizontal axis. Okay, let's create the initializer. For the parameter, we have name, string, and then list is an array of board lists. And then let's set the default value as empty. Let's assign the name to the name property as well as the list. Let's try to build. Okay, the build succeeded. Okay, so we have created all the models for this app. Let's move on to the next task. For the next task, we will be adding drag and drop support to the board list and card classes. There are two things that we need to implement for this. First, we need to add a unique uniform type identifier for both of the classes. This will be used by the system to determine the type of the object that we are dragging and dropping. For example, to drag a string type, you can just use the default public.text uniform type identifier. You can check the full list of the system provided supported uniform type identifiers from the Apple documentation that I provided at the description. Next, all the models also need to conform to the NSItemProvider reading and writing protocols. For this, we also need to make the models conform to the codable protocol for decoding and encoding the object. So let's implement this by navigating to the card first, add the conformance to the codable protocol, and let's try to build. Okay, it threw an error. Type card does not conform to the protocol encodable. You might be wondering why it threw an error. Because this UUID type and string are already conform to the codable protocol. They are the system provided type. So the issue is because for this content property, we are using publish property wrapper. Currently, Swift doesn't automatically implement the decodable and encodable implicitly when we are marking a property with publish property wrapper. So we need to decode and encode the object explicitly. To do that, let's just declare a enum name coding keys with the type of string and conform to the coding key protocol. We will have three cases: ID, board list ID, and the content itself. And next, we need to implement the required init from decoder method, initializer. And here, let's grab the container, put in a constant, and invoke decoder container kit by passing coding keys.self as the type. Next, we need to set the self.id by invoking container decode. For the type, we need to pass UUID.self. For the key, we just pass the ID. Let's do it also for the board list ID. Try container decode UID.self for keyboard list ID. And last, we have the content. Try container decode. For this, the type is string.self for key content. Okay, we have implemented the init from decoder initializer. Next is encoding. So we need to implement encode to the encoder method. Here, let's declare a var container and then invoke encoder container kit by. Here we just pass coding keys.self. And next, invoke container encode ID for key ID, container encode board list ID for key board list ID, and finally container encode content for key content. Okay, let's try to build. The build failed. Okay, for this we need to mark the invocation with try as it can true. Okay, for this we need to mark the for this we need to mark the invocation with try as this can true. Okay, let's try again. Okay, the build succeeded. Next is we need to implement the NSItemProvider Protocols for this. So let's declare the extension for the card and make it conform to the NSItemProvider writing. So the first thing we need to do is we need to provide the type identifier, a unique uniform type identifier for this card model. So let's declare a static let type identifier. I'm going to prefix this with this app bundle ID. For me, it is com.alvianlosari.trelloclone. And for the suffix, I will use the name of the model, which is card. Okay. Oh, there's another error. Cannot declare conformance to NS object protocol in Swift. So actually, this NS item provider writing requires this class to be a subclass of the NS object because it has this NS object protocol conformance. So let's make this card as a subclass of NS object. Okay, NS object. Because we are the subclass of NS object, this card, we also need to invoke super.init inside the initializers. Also for this init from decoder. Okay, let's try to build again. Okay, this is a different error. Next, we need to declare a property name writable type identifiers for item provider that returns a array of string. Okay, so let's make this computed and just return an array containing the unique type identifier. And for the required method for writing, we need to implement this load data with type identifier for item provider completion handler. So here we need to encode the object into a data and then pass it inside the completion handler. So let's just declare a do try catch block. Okay, and in the do block, let's declare a constant name encoder, initialize a JSON encoder. Let's make this encoder pretty printed the output. So let's assign encoder dot output formatting as pretty printed. Okay, and finally we need to invoke the compilation handler passing the data by invoking try encoder encode self. Okay, this will return the data. For the second parameter, this is the error, we just pass nil. Okay, inside the catch block, we invoke compilation handler pass nil for the data parameter, the first one, and for the second parameter, the error, we pass the actual error. And so actually this method requires us to return this progress. This is an optional. So we don't need the progress. So we just return nil. Let's try to build. Okay, we have implemented the NSItemProvider writing. Next is the NSItemProvider reading. So declare an extension named card and conform to the NSItemProvider reading. We need to implement the required static var, readable type identifiers for item provider with the type of array of string. So let's just make also this computed and just return the type identifier. And for the required method is this object with item provider data type identifier. Here we simply need to decode this data into the actual card model. So let's just invoke try initialize the JSON decoder and then invoke the code. For the type, we just use self, which is the card, and self for the type, and pass the data. And let's try to build. Okay, the build succeeded. We implemented both of the NSItemProvider protocols. This NSItemProvider writing will be invoked when the user drags this card, and this NSItemProvider reading will be invoked when the user drop this card. Okay, next let's move on to implement this for the board list. Let's confirm to codable, and this also have two published properties, so we need to implement the initializer, the decoding and encoding explicitly. So let's declare the aninum coding keys with type of string and implement the coding key protocol. We have four cases: ID, board ID, name, and cards. Okay, let's implement the init, required init from the coder. Let's grab the container, try decoder, container kit by passing coding keys.self. And first is the ID. We just need to invoke container decode uid.self for key ID, and then the board ID, try container decode uid.self for keyboard ID, and next is the name, try container decode string.self for key name, and finally we have the cards. This is an array, try container decode an array of card itself for key cards. Okay, that's all for the init from decoder. Next is encode to encoder method. Let's grab the container. We don't need to try. We just need to invoke encoder container kit by passing coding keys.self. And next, we need to prefix with try container encode the ID for key ID and try container encode the board ID for keyboard ID and name for key name, and finally encode the cards for key cards. Okay, the build succeeded. Let's also make this conform to the NS object, as we are going to implement NSItemProvider Protocols. And make sure to add the invocation to super init inside both of the initializers. Okay, next let's create an extension for the board list. Make it conform to the NSItemProvider writing. Here we also need to declare a unique uniform type identifier. So I'm going to prefix it with the com alfian losari Trello clone. This is my bundle ID. And for the suffix, I'm going to use the name of this class, which is BoardList. And next, the required static var is writable type identifier for item provider. Here I just written an array containing this type identifier. And next is this load data used for encoding. Let's declare I do try catch block and return nil. The catch block I just info completion handler passing nil and error for the second parameter. And inside the do declare encoder, initialize encoder, and set the oncoder output formatting as pretty printed, and just info completion handler try encoder encode self. And for the error parameter, second one, just pass nil. That's it for the NSItemProvider writing. Next is NSItemProvider reading. We need to implement the readable type identifiers for item provider. Just return the type identifier inside an array and implement the required object with item provider data type identifier. Just invoke try, initialize a JSON decoder, invoke the code, passing self.self from data. Okay, we have successfully implemented both of the NSItem provider protocols to the board list and the card models. There is one final step to make this work. Basically, we need to add the exported type identifier containing these custom type identifiers to the info plist. It's pretty simple to do. Just navigate to this project setting and select the targets, and then click on this info from this tab and expand this exported type identifier section. Click this plus button. So for the first one, let's go to the card. Let me copy this type identifier string and here let's just paste this inside the description and the identifier. Okay, this is for the card. And for the second one, click on this plus button again and go to the board list. And we need to copy this board list type identifier and expand this again, paste this into the description as well as the identifier text field. Okay, that's it. We have added this exported type identifier for our own models, and we should be able to implement drag and drop later in this tutorial. So before we implement the views, let's create the stub data for the board. This will help us start the app with pre-filled data. So let's navigate to the models here and then create a new C file, give it a name of board plus stub, and declare an extension for board and declare a computed static var name stub with the type of board. First, we need to initialize a board, assign it to the constant name. For name, give it any name that you want. For me, I'm going to give it a name of Axia board. And let me find some emoji. I'm going to use this rocket emoji. Okay, one, two, three. Okay, we have the board. So first we need to declare the first board list. I'm going to give it a name of backlog board list and initialize a board list in this. For the name, I'm going to give it a name of backlog and pass the board.id for the board ID parameter. Next, I'm going to declare the cards inside this list. So let me declare an array. Here I have to declare cloud service. So I just give a random name here and then ingestion engine and compression engine. Next is database service. These names actually doesn't mean anything. So next is routing engine and next is schema design and web analytics. I want to make this a bit longer so can fit more than one line. Open the dashboard and CMS. Okay. So we have this array. Now we just need to map this to cart by invoking map and then initialize the cart. For the content, let's pass this $0 and for the board list ID we can pass the backlog board list dot ID. Okay, we have the backlog cards. Next is we need to assign this backlog board list with these cards. Okay, let's continue. For the next board list, let's declare a constant, give it a name of to do board list, initialize a board list instance, give it a name of to do, and pass board.id as the board ID. Next is to do cards. Declare an array of strings. First one is error handling. And the second one is text search. And for the map, I think let's just copy this, paste this, and make sure to change the board list ID as to do boardlist.id. Make sure to assign to do boardlist.cards as to do cards. Okay, let's continue. The third board list is in progress board list. Initialize a board list give it a name of in progress, passing board.id, and in progress cards. So we're simulating a real Kanban board here. Here, I think let's just declare one string, file storage service. Okay. Let's also copy this map. Make sure to change this as in progress boardlist.id. And finally, assign the in progress boardlist.cards with in progress cards. Okay, for the final board list is done board list. Just initialize board list, passing the name as done and passboard.id. And let's make the cards empty for this. And finally, we can just set the board dot list property by assigning an array containing all the board lists, starting from backlog to do, in progress, and finally done. And finally, just return the board. Okay, let's try to build. Nice, the build succeeded. Okay, that's it for the board stuff. Next, let's focus on building the views. Let's begin by building the board view, which will be the root container view of our app. Let's go to this project navigator here and create a new folder, give it a name of views, and inside this views folder, create a new SwiftUI view and give it a name of board view. We're going to make this view as our root view here. So let's replace this content view inside the window group with the board view. And we can delete this content view as we won't be needing this. Okay, now let's go to the board view and implement this. First, let's enable the live preview. For this, I'm going to use iPad Pro 12.9 inch simulator and make sure to enable the canvas here. Click here. Okay, so let me click resume here. For the preview, I want it to be in a landscape, so let's just click in here. This will change the orientation to landscape left here by adding this preview interface orientation modifier inside the previews. The value that is being added is landscape left. Okay, we have the preview. Next, let's declare our first property. Make this private and give it a name of board. And we are going to mark this with the stat object property wrapper because our board is an observable object. For the value, we're going to use stub as we are developing this for the first time, right? Okay, we have this. Because we added new property here, we need to build again here. Click on resume again. Now, I want to declare some global constant for the background colors. The first one is the board list background color. This will be the background for the board list, that grayish background. Let's initialize a SwiftUI color using this UI color as the parameter. Let's initialize UI color. For the red, let's pass 0.92. For the green, let's pass 0.94. Sorry, for the green, it should be 0.92 also. For the blue, that is 0.94, and for alpha, that is 1. And for the next background is the background of the board itself. For this, I'm going to use the Trello background, blue background color that I got from the web. So give it a name of Trello blue background color. Initialize a color using the UI color initializer and initialize an instance of UI color again. For the red, it is going to be 0.2, and for the green, it is going to be 0.47, and for the blue, it is 0.73. For alpha, just pass 1. Okay, we have this global constant for the background. Let's try to build. Okay, build succeeded. Just to make sure, click on resume again as we are adding new constants, new global constants. Okay, for the body of the board view. For the root view, I want it to be a navigation view. That will be the root view of this board view. And as we won't be showing the sidebar navigation inside an iPadOS, we need to add additional modifier to change the default behavior. So by default on iPadOS, it will be showing sidebar when we are embedding the views inside the navigation view. So to override that, let's pass navigation view style and passing stack as the value. So this only shows a single top view. Okay, we have the navigation view style now. Inside the navigation view, let's begin by declaring a scroll view. And for the axis, it's going to be horizontal. Let's add several modifiers to this scroll view. For the background, let's pass the Trello blue background color here. But also, optionally, if you want to use image as a background, you can also. So let me show you. Here, inside the assets catalog, open it and add a new image set. Give it a name of the image. And you can grab any image that you want. For me, I already have an image that I want to be shown as a background. This image that I got from the internet showing Apple mothership, Apple headquarters in Cupertino. So this is being added as 2x. Let's go back, and here I can just comment here and invoke background, initialize an image, and for the name, I'm going to pass image. And let's resume this so we can see it in the live preview. Okay, this is being shown, but as you can see, there's a white space in here. It doesn't fill the container. So to solve this, we can just add resizable modifier. So SwiftUI resizes an image to fit its space. Okay, this looks good. Next, let's add the edges ignoring self area, passing bottom here. Okay, looks good now. And let's add a navigation title, passing board dot name. Okay, currently it shows this large navigation title. We don't want this behavior, so let's add navigation bar title display mode, and let's pass inline here. Okay, yeah, this looks better, more like Trello. And I think this is all the modifiers for the scroll view. Now let's begin to implement the view inside the scroll view itself. So inside the scroll view, we will have a horizontal stack, but in this case, we are going to use lazy edge stack to make it more efficient. So the views that being shown on screen, that will be the only one that got loaded into the memory. Okay, let's say edge stack. I'm going to pass alignment with top, and I want to max the spacing between each of the view to be 24. Okay, let's also add this padding modifier to this lazy edge stack. Okay, now let's begin implement the views inside the lazy edge stack. I'm going to use for each here passing the board dot list. That is an array of board lists from the board, and inside this view closure view provider, I'm going to give it the name of the parameter to as board list. And for now, let's just display it as a text passing board list dot name. We are going to implement the board list view next. Okay, as you can see here, the board lists are being rendered here, the items. And below the for each, I'm going to declare a button. I'm going to use this title action. For the title, let's pass this add list. Okay. And for the action itself, let's pass an empty closure for now. And let's add padding to this button. And let's set the background. Oh, before that, I want to add a frame max width passing infinity. Okay, I have the padding added. We have the background added. Let's make this a bit bigger. Oh no, I think the previous size is better. Okay, we have the padding, we have the background. For the background, I'm going to pass board list background color, and I'm going to set the opacity to 0.8 to make it a bit more transparent. And next, I'm going to set the frame width to 300. Okay, and let's also add a bit of corner radius passing 8, and let's set the foreground color, the text color, to black. Okay, thinks this looks good for the initial implementation of the board view. Okay, let's move on to the next task. Next, let's begin to implement the board list view. Let's open the project navigator, and then inside the views folder, create a new SwiftUI view. Give it a name of board list view. Okay. Inside this board list view, let's declare the properties first. The first one is a observe object var with the name of board and type of board. Why we declare this as observe object? Because we are going to pass the observe the state object from the board view. And next, we are going to declare state object for board list with the type of board list. We are also going to pass this from the board view, but the board view itself won't managing the life cycle of this state object. This board list view itself will have its direct relationship with this state object, this board list. Okay, now let's paste the error inside the board list view previews. So first, let's declare a stat object static var here with the name of board and assign it with board.stub as the value. And here we can simply pass this board as an observed object, and we simply can pass the board list from the board itself by accessing the list array here, the property. This is an array, and let's pass the first element in the array by using this index 0 as the array subscript. Okay, we have the board list view, and let's click resume first to show the live preview. For this, I don't want the preview to be rendered using the full screen simulator. So to do this, I can just pass preview layout and pass size that fits. And I want to limit the frame here with a width of 300 and height of 512. Okay. And what else? I think we have the live preview here. Okay, let's zoom in here. And then I think we can implement the body now. So inside the body, let's declare a vstack as the root view. And let's pass the alignment as leading and spacing between item as 16. Let's add several modifiers to the vstack. First one is padding, vertical, and then let's pass the background as the board list background color. This is the global constant that we declared before inside the board view. And let's limit the frame here to be 300. And let's pass the corner radius as 8. And I think we can set the foreground color for the text to black. Okay, that's all the modifier for the vstack. Let's implement the vstack now. The first one is the header that will be shown at the top, containing the text and a button inside a horizontal stack. So let's declare a h-tag and set the alignment as top. And inside the h-tag, let's declare a text passing board list, the name of the list, board list.name. Set the font as headline, and let's set the line limit to 2. And let's push the remaining item to the trailing edge using a spacer. And for the button, I want to use a SwiftUI menu. So when you tap on the menu, it will show like a pop over, I think, containing the button that we want. So we will have 2 buttons inside the content. And for the label of the menu, I'm going to use a image here. Passing image using a SS symbol, system name. I'm going to pass ellipsis dot circle, and I'm going to set the image scale passing large. Okay, now let's add a bit of horizontal padding first here in the edge tag. Okay, and then for the content here, I'm going to pass button using this title action. For the first one, the name is rename. And for the action closure, we implement that later. The second one is delete, and let's pass the role as destructive. Okay, we have this. So let me show you how the menu behave. Let me click on this resume. So when I click this, it will show this kind of pop over containing the buttons. Okay, let's continue. And what else inside the header view? I think this is all inside the header view. And I think we should abstract this out to a separate property. So below this body, let me declare a private var header view. The type is an opaque view using the sum keyword. Here I can just start to select from this entire h tag declaration and then cut this. And I'm going to simply declare the header view. I'm going to pass this inside the header view. Okay, looks good. And the next view is the list view containing all the cards for this board list. So for this, I'm going to declare a list. And inside the list, I'm going to use for each passing board list dot cards. This is an array of card. And inside the closure, name the parameter as card. And for now, I'm just going to render a text containing card.content. We will implement the card view later. And below the list, I think we should add several modifiers for this. First one, let's remove the separator using this list row separator modifier, passing visibility as hidden. And the next one, let's pass an inset between the row. Here I'm going to initialize inset. I'm going to pass 4 as the top, leading 8, and bottom 4, trailing 8. Okay, what else? I'm going to set the list row background itself using color.clear. Okay, and I think we should also move this to a separate property. So our body doesn't get very big. So create a private var list view with the type of opaque view using sum keyword. Okay, and then cut this list and paste it inside the list view property. Make sure to declare this list view below the header view. And let's add uh, this style modifier here on the list, passing plain, because the default one is inside group starting from iOS 14. Okay, now let's try to resume the live preview. Okay, now let's declare a button below the list view. Let's pass the title as add card and let the action closure be empty for now. And let's set the padding as horizontal, and let's set the frame passing max width as infinity and alignment as center. Okay, I think, yeah, this looks good. Now let's move on to implement the card view. So open the project navigator, and inside the views folder, create another SwiftUI view. Give it a name of card view. And let's declare the properties. First one, we're going to declare non-observed object, and this will be the board list. We're going to pass this as a binding. So actually, you can think this observed object itself as a binding. And when you declare a state object, there is a state. Okay, so we will pass the board list as the binding. Okay, and next we have the state object. So this will be owned by this card view, and it will be managed by this card view itself. And this will be the type of the name is card, and the type is card observable object. And now we need to fix the preview here. Let's declare a stat object static var and give it a name of board list and initialize it with the board.stub and access the list, the array of board lists, and assign it with the first element using 0 as the index. Now we can initialize this card view passing the board list, and for the card we can access it from the board list dot cards. This is an array of card inside a list, and let's also pass the first card. Okay, let's try to resume the live preview. Okay, let's also make this to be not rendered inside the full screen of the simulator. So let's pass preview layout and pass size that fits. Let's also set a frame with the width of 300. Click resume. Okay, looks good. Now we can implement the body. So the root view for the body, let's just declare an edge tag. We have a text and a button again, the menu. Inside the edge tag, the first view is the text. Let's pass card.content and also set the line limit as 3. Okay. Oh, before that, let's add several modifiers to the edge tag. Let's add padding, passing 8 to all edges. And let's set the frame, passing max width as infinity, and set the alignment as leading. Okay. And set the background color white. And let's also add a corner radius of 4. And finally, let's add a bit of shadow to this card view. And let's use this one, ignore the color. Let's just use the default color. For radius, let's pass 1. For x, let's use the default x position, x coordinate. And for y, we are going to push it a bit down. So let's pass 1. Okay, let's continue on the edge tag. Let's declare a spacer to push the remaining item. And let's declare the menu again. We have the label here and the content closure. For the content closure, let's declare 2 buttons. First one is edit. I think we should just give it a name of rename. And for the action closure, let's just pass empty for now. Second button is delete, passing the role as destructive. And let's also pass an empty closure for now. Inside the label, we're going to show an image using an F symbol of ellipsis dot rectangle. Okay, I think this looks good now for our card view. Oh, I think this image we can just make it a bit smaller, passing the image scale as small. Okay, this looks good. Let's move on to the board list view, and then inside this list view, let's replace this text with card view, passing the board list as well as the card. Let's stop the interactivity now. Okay, now it looks good. Nice. And now for the final integration, let's navigate to the board view. And in here, let's replace this text with the board list view. Can pass the board as well as the board list. Wow. Let's change this zoom to 100, 50. Okay. Okay, this looks good now. Currently, the list always fills the remaining height from its parent, regardless the number of the card's content, unless we explicitly set the frame height, because it is currently how Apple implemented lists in SwiftUI. We'll fix this next by adding a dependency to a Swift library named Introspect that let us inspect the UI kit internal of the SwiftUI view. So we should be able to get the content view of the scroll view and then set the list head dynamically. So we will be adding the third-party dependency using SPM Swift Package Manager. That is the native package manager for Swift. To do this, let's just open the project setting in here and make sure to select this project and click this package dependencies here from the tab and click this plus button, and here we need to enter the URL of the package that we want to add. So I'm going to use https github.com and /site line /SwiftUI hyphen introspect. Okay, you don't need to worry. I have provided the link to this repository at the description below, so you can just copy and paste instead of typing. Okay, this is the library SwiftUI-Introspect. And for the dependency rule, let's just use branch and make sure to select master here and make sure the add to project is selecting the Trello clone. Click add package, make sure this is checked. This is Trello clone, add the package. Okay, as you can see here in the project navigator, we have this package dependency section containing all the third-party dependencies that we have added. Here we have Introspect. Okay, let's just collapse this. And now we can integrate this. Let's go to the board list view. And let's declare a state var list height with the type of CG float and the default value of 0. And let's resume the live preview. Okay. What is still rendering using a full screen? Even though I have set the size that fits, probably a bug from SwiftUI. Okay. As the content of the list is dynamic depending on the number of the cards here, we will add a introspect table view modifier on the list to get the underlying UI kit table view. After that, we can set the list height here, the state property, with the table view content size.height property. Finally, we will add the frame modifier to this view here, passing max height and using the max height, and then pass this list height as the value. So with that, we should be able to dynamically control the height of the list based on the content size. Okay, now let's implement this. Let's import Introspect at the top. So by importing Introspect, we will have the access to the Introspect modifiers. And inside this list, on the for each, let's add a new modifier, which is Introspect table view. This will get the underlying table view inside a list in SwiftUI. As you can see here, the type of parameter is UI table view from UI kit. So that is the internal implementation. So basically, SwiftUI still uses UI kit for internal implementation. And we can simply set the list height state using the content size of the table view. Okay, now we just need to go to this list view declaration and add a new modifier, passing using max width and passing the list height that we set dynamically at the runtime. Now we need to try this. Click on resume. As you can see, now the list height is always set to 0 because this needs the apps to be run for this closure to be triggered, this introspect. So for this BoardList preview, let's pass the state height here. Sorry, the list height inside the preview as 512. Okay, so we can still preview it in the SwiftUI preview. Now let's try to. I'm sorry, I think this is not max width. This should be max height. Okay, now this looks good. As you can see, there is no blank space. Now it fills the content. Now let's try it inside the board view. Okay, as you can see here in the live preview, the list size are set to 0. Let's try to run this. Nice, it works. As you can see right here, each of the list size are dynamic depending on the content of the cards, the number of the cards. The head of the board list is set dynamically. Okay, this looks good. We have successfully implemented most of the basic UI element. Now let's move on to the next task. For the next task, let's implement the CRUD functionality for the card. Let's navigate to the board list model to add several methods. The first one, let's declare a private, let's not make it private, sorry. Let's declare a func card index, and the parameter is an ID with the type of UUID. This will return an optional integer. So basically, this will help us to find the related card given an UID inside the card's property. You can just invoke cards first index of. In this case, let's pass this where closure where the card.id equal with this ID from the parameter. Okay, and the next method is add new card with content. The parameter is content with the type of string. Here we can simply invoke cards.append. And for the new element, let's initialize a card instance, passing the content from the parameter. And for the board list ID, we can simply pass our ID, self.id. Okay, Next, let's declare another method for removing the card. Remove a card with the parameter of card and type of card. We can simply get the index first, index to remove. So let's invoke card index, passing the card.id. In case we don't find the card with that ID inside our cards array, we just return. And finally, we can just invoke cards in this array, remove in the card index. Okay, and the final helper method that we're going to implement is this move cards from offsets. The parameter name is offsets. The type is index set, a collection of index, unique index. And then next one is to offset. This is the destination index. This is just a integer. This is pretty simple. We can just use the built-in move method from an array cards move. Okay, it matches the parameter here, offsets and to offset. Okay, we have all of these helper methods that will help us for implementing the root functionality next. But before that, we need to provide the UI for the users to input the text into a text field. To simplify this, instead of declaring a text field inside the SwiftUI view, we will using UIAlertController with UI text field attached to it. Why use UIKit? The reason is because Apple does not provide an API to use alert modifier combined with text field. Come on, Apple! I think this needs to be added for the next iOS 16 release. But enough for the run. Let's just implement this. And inside the views folder, create a new Swift file. Give it a name of view plus alert text field. And let's declare an extension for the view. Okay, it gave an error, cannot find type view in scope. So we actually need to import SwiftUI as well as importing UIKit. So we will be creating a method here. Give the name of present alert text field. And the first parameter is title, the type of string. And second one is message with the type of optional string. And let's provide the default value of nil. And the third one is the default text field text. This will be the initial text that will be rendered in a text field. And this will be really useful when we are editing the name. So we can pass the current name. Let's pass the value as optional string with the type of default value of nil. And finally, let's declare a confirm action closure, make this as an escaping closure. And the parameter is an optional string with the return value of void. Okay, let's start the implementation. This is we are going to use UIKit approach in here. So basically the point is just to grab the main window, of the app, and then grab the root view controller, and based on that we can create a create an UI alert controller instance and present it using that root view controller of the window. Okay, so let's just begin. Let's declare guard let, give it a name of root PC, and in here we need to grab the first UI window scene. Okay, this can be a bit long, so let's just use UI application, get the shared application instance singleton, and we can access this connected scenes. But we are going to just get the first one, and let's cast this as UI window scene. Okay, and then as this is optional, we need to add this question mark and then invoke key window, the key window of this scene, and that is also optional. So we need to add that question mark dot. Finally, we can access the root view controller of the window. And in case one of these fails, we can just return. Okay, now we have the root view controller, the UI view controller. And first, let's just initialize UI alert controller. For the title, we can pass it from the parameter title, message. And for the preferred style, we need to pass alert. Okay, and continuing on, you can just invoke add text field here. And let's grab the text field inside the configuration handler closure. And here we can set the initial text by passing the default text field text parameter. Okay, next one, we need to add the action. Okay, the first action is cancel. Let's pass the title as cancel. For the style, let's pass cancel. And for the handler, let's just pass an empty closure. Okay, let's clean this a bit using a trailing closure. Okay. I think we need to add closing parenthesis to the closure. Okay, continuing on, let's add the second action, initialize URL action. Here, let's pass save as the title, set the style as default, and inside the handler here, we simply can ignore this. We are not going to use anything from that. And inside the closure, we need to grab the text field first. Grab that text field. We can access the alert controller text fields. And let's grab the first one. In case it fails, we just return. And finally, we can invoke the confirm action closure, passing the text field the text. Okay, there is an optional string. Okay, we have the actions, we have the text field attached. Finally, we can just invoke root vc present, pass the alert controller, set the animation animated as true, and for the completion, let's just pass nil. Okay, this is our method to present UIKit art text field with a configuration handler. Okay, the build succeeded. Now let's implement the card root action using this helper alert text field. Okay, now let's begin the implementation of the card root from the board list view. Okay, exercise this and let's declare a private func first and give it a name of handle at cart with no parameter. Here we can simply use our new helper function %alert text field. For the title, we can simply pass at cart to, let's use string interpolation board list dot name at cart to the board list dot name. For the message, I think let's just ignore it. Use the default nil value. For the confirm action, let's grab the parameter, name it as tags. Now we need to check. We need to override that using gotlet. And also make sure that the text is not empty. Continuing on, we can simply invoke board list, add new card with content, passing the text. Okay, that is for the create method, create card. Now we need to implement edit content and delete card. To do that, let's navigate to the card view.swift. Here we have this button, these two buttons, and let's declare a private func handle rename card. Actually, we are not renaming the card, right? We are editing the content of the card. So I think better name is edit. And here, let's also change this to edit card. Here we can simply invoke handle edit card inside this action closure for the edit button. And let's just invoke %alert text field. And for the title, let's pass edit card. And for the message, let's just pass nil default value. And for the default text field text, we need to pass the current content. So we can just simply use car.content here. And for the confirm action, let's grab the text parameter, check, and wrap it using guardlet and check if it is not empty. And continuing on, let's invoke card dot content is equal with the text. Okay, and for the delete here, I think we can simply invoke board list dot remove card, passing the card. Yep, I think we have implemented create, read, create, read, date, and delete. Okay, let's try this using the simulator. So build and run. Okay, the simulator runs now. Okay, let me rotate this to landscape orientation. Let me resize it. Okay, first let's create a card. It doesn't work. I forgot to add this invocation, I think. Sorry. Let's go to the board list view and find the button here. Here, add card. Simply invoke this handle add card. Go and run again. Okay, now let's click. Nice. There's this alert controller with text field. So add card to the board list. And let's add something in here. Let's say what is it? Let's say machine learning. It's a buzzword. Okay, save. Okay, it is being added to the list correctly. Here, machine learning. And next is edit. Let's click on this menu here, edit. Okay, there's this text, machine learning as the initial text for the text field. So let's rename this to artificial intelligence. Okay, it's successfully updated the card content. And finally, let's delete this. Okay, nice. Everything worked. We can create a new card, we can edit the content, and we can delete. Next is we need to implement card reordering by using drag and drop inside the list. This should be pretty simple to implement when using a list view. So, okay, we are already in the board list view in here. Scroll down to the list view and then we simply need to add this onMove modifier. So basically this is we need to pass a closure method with the two parameters, the from offsets, index set, and the destination offset, destination index, which is a type of integer. And we already implemented that. So we can simply pass board list the move card from offset to offset method. Okay, let's try to build and let's try to drag and drop inside the same list. Whoops, I have tried to long click in here, nothing happened. The card is not being dragged, so it doesn't work out of the box. So actually, this onMove modifier requires the list to be inside an edit mode. To invoke edit mode, we can use a special button, which is this edit button that we can initialize. This is a button that toggles the edit mode for the current edit scope. But in our use case, we don't have any edit mode. The user can just drag and drop any card, regardless of the edit mode. I mean, it is always in the editing state. So how can we do that without the edit button? It's pretty simple. So actually, inside this for each, the view here, the card view, we can simply add this on drag modifier. Okay, this is a closure that we, we need to return an NS item provider. So as the card already conforms to the NSItemProvider protocols, we can simply initialize an NSItemProvider and pass the object in here. This object needs to conform to the NSItemProvider writing for the drag to happen. So let's pass the card here. It already conforms to the NSItemProvider writing, so it can be encoded into data. Okay, now let's run it again. Okay, now let's long click here or long tap. Nice, I can see the preview. And here, as you can see, I can move this around inside the same board list. Wow, the animation looks very smooth. This is really the power of iOS. But currently, we cannot drag this and drop this to another view. It doesn't work. Next, let's implement the ability to drag and drop a card to another list. When the user drags an item from the source board list and drop it onto the destination board list, We will remove the card from the source board list and insert it to the destination board list. So let's implement this by navigating to the board class and add several methods. Let's begin by declaring a private func in here, board list index, given an ID of the board list. Here we can simply set the return type as optional integer and simply invoke list. This is the board list array, and invoke first index, pass the word closure, and compare the ID. Okay, we get the board list index. The next method is private func card index, given a card ID with the type of UID and board index with the type of integer. And the return type it is optional integer. Here we can simply use list, passing the board index to retrieve the related board list, and we can invoke card index passing the ID of the card. Okay, the build succeeded. Now we can implement the actual move method now. So here, let's declare a func move card with the type of card to board list, the destination board list, and add the destination index. Okay, first let's declare guard for the first let. Let's declare a let source board list index. This is the source board list of the card. Here we can simply invoke board list index passing card dot board list ID. Next is destination board list index. Here we can simply also invoke this board list index passing board list destination board list.id. And next we need to compare this source board list index is not equal with the destination board list index, just to make sure we are not drag and dropping into the same view, same board list. And finally, we need to get the source card index. Where we're going to remove it, we can simply invoke card index passing the ID of the card.id. For the board index, we can pass source board list index. And let's have else and just return. First, we need to insert the card into the destination board list. So we can invoke board list.cards, insert card, pass the card, add the index, this index. And next, we need to set the card board list ID with the destination board list.id. Next, we need to remove the card from the source board list. Let's use this list property and grab the related board list using the source board list index and access the cards array and invoke remove at passing source card index. Okay, that is the move method to move a card to another board list. Next, let's implement this into the board list view. So basically, when using a list view, this becomes very easy. We can simply implement on we can simply add an insert modifier on the list, passing the uniform type identifier for the type, which is the card, insert an array, and perform the action given an destination index and an array of NSItemProvider. Okay, so for the closure, let's declare a method to implement that. Let's give it a name and handle on insert cart with the parameter of index and type of integer and item providers with and type of NSItemProvider array. Okay, and let's implement the on insert in here. As an array containing card.type identifier, and for perform we can pass handle on insert card method. Okay, what should we do in the handle on insert card? First, we need to loop the item providers array, and this is an item provider. We need to invoke item provider load object of class. The type needs to conform to NSItemProvider reading.type, and card already conforms to this. We have implemented that. So we can simply pass the card type using card.self. In the completion handler, it passes us two parameters, the item, which conforms to NSItemProvider reading, this is optional, and the error. So let's grab this item and let's ignore the error. Here we need to pass this item to cart. Let's use guardlet cart item as cart, and if it fails, we just return. Finally, we need to invoke board.moveCard, and because that method update the published properties, which is the list, we need to invoke that inside the UI thread. And actually, this closure can be invoked in a different thread. So let's make sure to call that in a main thread by using dispatch_queue.main.async. Here we can simply invoke board.move, passing the card to the board list. This is the board list that the user is dropping it into, and add, you can pass the index. Okay, now let's try to build and run, and let's drag this error handling, move it to the backlog. Wow, nice. We can insert it anywhere in here. Okay, let's drop it. Nice. It removed the error handling from the to-do board list and insert it into the backlog board list. But actually, while this works, there's some issue. So let's say this file storage service, I want to move it to the down board, which is currently empty, right? As you can see, I cannot do that because the head of the list in this down board is 0. It has no cards. So another issue, right? Actually here, let's say this to-do board list only has one item, one card, and I want to drop an item there. As you can see here, when I drag this before releasing it, the height of the board list itself doesn't get bigger, right? Only if I drop it, and sometimes it doesn't work. So to solve these issues, let's make this entire board list view to be droppable. So let's say when I have this, I will just drop this in the header here. It will also insert the card into the board list. And one thing for you to know, right? Actually, there's also a bug with the list view in iOS as of iOS 15.1, I think currently. So when we are inserting an item into an empty list, let's say we hard-coded the frame to a specific size, right? It will crash actually. I think Apple needs to fix that bug. Okay, enough about the run. Let's implement the drop delegate to handle that. To handle the drop action, we can use the SwiftUI on drop modifier that accepts the uniform type identifier array. So let's implement this. First, we need to create an object that conforms to the drop delegate protocol. And inside the models folder, create a new Swift file, give it a name of board drop delegate, and just declare first let's import SwiftUI, and let's declare a struct, give it a name of board drop delegate, and make it conform to the drop delegate protocol. So actually, where this drop delegate protocol provide a more granular control for us to handle the drop action. Let's open the public interface. So here there's this validate drop, perform drop, drop entered, tells the delegate a validated drop has entered the modified view, drop updated, drop exited. So the entire life cycle of the drop action. Okay, so first let's declare the properties we need. First one is the board, and the second one is the board list. Okay, this is the destination board list. And let's create a private method, private func, and give the name of card item providers with the parameter of drop info and return type of NSItemProvider array. Here we can invoke this drop info dot item providers for types. Okay, for types we are going to pass card dot type identifier. So basically this drop delegate can accept multiple type identifiers, right? We also use this letter to handle the board list reordering. So here we want to check the item provider for specific type. So we can provide a proper handling for that particular type. It should be card. Okay. And the only required method that we need to implement in here is the perform drop, I think. So this will be invoked when the user lifts their finger from the screen. Okay. But before that, I also want to implement this uh, drop updated. So tells the delegate that a validated drop move inside the modified view. So in this case, I want to check if card item provider passing the info is not empty. So this means that the user is currently dragging a card. In this case, sorry, here I just want to return nil in the else case. But inside the card item provider is not empty, right? It is not empty. The card is dragging a card. Here I want to initialize a return and initialize a drop proposal. And for the operation, it will be copy. Okay. And inside the perform drop itself, let's declare constant card item providers. And let's grab this from this helper method. And let's loop this. And we simply need to use the same approach that we used on insert list modifier closure. Here we need to invoke card item provider load object of class passing card.self and this is the item. Ignore the error, and we need to use guard let on the card on the item. I mean, cast that as a card. And there's one extra validation I want to do in here, just to make sure that the card board list ID is not equal to the board list ID. The card source board list ID is not equal to the board list ID. Just to make sure the user is not dropping to the same view, to the same board list. Okay, and else we can just return. And finally, we can invoke dispatch queue dot main dot async and invoke board move card to board list at the index. We don't have the index, right? But I think we can just insert that to mm, the first index. Okay, it's up to you if you want to also insert that to the tail, to the last index. I think that will be more efficient than inserting at the first index because it doesn't need to remap the array address. And finally, we need to return true here. And let's just build. Sorry, we just want to build, not run. Because next we are going to go to the navigate to the board.swift, sorry, board view.swift. And in here, we need to add the onDrop modifier to the board list view. This one, right? But if you can see, there is another methods for onDrop that basically just provide a closure without implementing the drop delegate. So this is basically will just be invoked when the user lift their finger from the screen. But in our case, we want a more granular control, so we use a drop delegate. Okay, for the uniform type identifier array, let's pass card dot type identifier. And for the delegate, we can simply initialize board drop delegate, passing the board and the board list. Let's try to build and run now. Okay, let's drag this file storage service and move this to the empty board list. Nice, it works, right? This entire board list now accept this card when it's dropped there. Here also can just move here. It will be inserted to the first index inside the board list. Okay, we have successfully implemented the feature to move a card to different board lists. Let's move on to the next task. Okay, so for this task, let's add the crowd functionality to the board list. So we should be able to create, update, and delete the board list. So let's begin by navigating to the board class here and add several methods. The first one is add new board list with name. The parameter is name with a type of string. Here we can simply invoke lists.append and initialize a new board list. Here I'm going to use this one. For the name, let's pass the name from the parameter. For the board ID, it will be the ID of this board. Next is remove board list, and the parameter is board list with the type of board list. Here we can invoke guard let index to the let. We can use the helper private method board list index, pass the board list dot id to find the index in the list array, and just return in case it fails to find. Finally, we can just invoke lists remove at the index. Okay, now let's go to the board first. Board view dot swift. Here we have this method at list. So first let's declare a private func handle list. Here we can simply invoke the present alert text field. Title is at list, and the message, let's ignore the message, as well as the default text field text. And for the confirm action, let's grab the text parameter, use guard let. Make sure to also check that the text is not empty. And finally, we can invoke board dot add new board list with name, passing the text. And don't forget to add this invocation inside this add list button, handle on add list. Okay, next is for the rename and for the delete. There is inside the board list view menu button. Here we have that rename. So let's create another method here, private func handle board list rename, invoke person or text field. For the title is rename list. Ignore the message. Default text field text is the current board list name. And for the convert action, let's grab the text as parameter and lose godlet text. Make sure it is not empty. And we can simply invoke board list dot name equal to text. Okay, and make sure to invoke this in the rename button action closure under board list rename. And for the delete button here, we can simply invoke board dot remove board list passing the board list. Okay, that's all of it. Let's try to build and run. Okay, so let's scroll here and click on this at list button. Okay, we have the alert text field. Let me add a new list, key A, save. Okay, as you can see, the new board list key A is created. And next, let's rename it. Okay, the initial text is key A when we rename this. So let's edit this, put any text you want. I'm going to put in key A. Okay, the board list got updated. And finally, let's delete the board list. Okay, the board list got removed. But I think we can add more. I think we can add the animation. when we add the board list as well as when we remove it. And that is pretty simple to implement when using SwiftUI. So actually, let's go to the board view. So below this padding modifier on the lazy edge tag, we can simply pass this animation. Let's pass default as the animation type. And for the value, so we want to check when the board list changes. So basically when it is inserted, when one element is inserted or removed, or maybe one of the or order of the elements changed, which will be implement next for reordering the board list using drag and drop. Okay, let's add a new list. Okay, and when I click save, notice here it will be animated. Nice, the animation looks super smooth. Let's delete it. Nice, there's an delete animation there. Okay, now for the next task, we'll implement the board list reordering. So when the user drag this, we can move it around to reorder the board list. We are going to use the same drop delegate, the board dot drop delegate that we created earlier. So our strategy here is to pass the list and currently drag board list as binding to the board drop delegate. When the drop entered the board list view, we swap the drag board list with the one that the user is currently dragging to using the binding list. When the user leaves their finger, we just set the drag board list binding to nil. The original solution for this is I got this from an answer that I read on StackOverflow by Aspari. I've provided the link to the original solution at the description in case you're interested. So let's just implement this for you to see on how it works. So navigate to the board drop delegate.swift. So basically we need to pass two bindings. Declare a binding here and a var name list. This is the binding of the board list array from the board. We're going to pass this as binding so we can mutate this and the view got updated. Okay, and the second one is also binding. Let's give the name of current with the type of board list optional. This is the currently this is the current drag board item, the board list that the user is dragging on. Okay, so first let's declare another private function board list item providers with the parameter of info and type of drop info that return also an NSItemProvider array. We can simply invoke item info.itemProviders for type passing board list dot type identifier. And here inside the drop updated, I'm going to add additional else if the card item providers for the sorry it should be board list item providers passing the info. If this is not empty, then it means that the user is currently dragging a board list. And in this case, let's initialize a drop proposal and pass move as the drop operation. So actually this drop proposal, right? When I use copy, right, and drag this, right, as you can see, there's this plus button. So this plus button will be shown when we are using copy. But when we are using move, it won't be shown. And for the board list, I won't be showing that plus button. Okay. And the next method, there's one additional method that we need to implement, which is drop enter. So this will be triggered when the dragged item enter the drop area before it drop the view, the dragged item, sorry. So here we need to use guard statement. Just make sure that the user is currently dragging a board list using this board list item progress info. It is not empty. And let's make sure that the current drag item is exist, and make sure that this destination board list is not the same with the one that the board list that is currently being dragged on. And next we need to get the from index, the index of the board list, first index of the one that is currently being dragged on. This should be current. And the to index, the destination index, the list of the one that is currently being the destination of the board list being dragged into. Okay, so after we got all of this, we can just continue, else we just return. And here we can simply invoke list move from offset. So from the offset, we need to initialize an index set. Okay, here we need to pass the index, which is the from index. And for the destination index, we need to be careful. Here we need to use ternary operator. When the to index is larger than the from index, we're going to return the to index plus 1 as the destination index. Otherwise, if this before the if the from index is larger, we're just going to return to index without adding 1. Okay, so build fail. But before I check that error here, so in this perform drop, I just want to make sure that the current dragged item is set to nil. Okay, now let's check where the build error comes from. Okay, here we need to simply pass the bindings. First one is list. For accessing the binding, we can use the dollar prefix and board dot list. This will be the binding, okay, of the board list array. And next is current, right? For current, we need to create a new state private var, give it a name of dragging with the type of board list optional. Okay, let's pass this binding here, dragging. So when do we set the dragging? So basically here we need to add the on drag modifier to make this board list draggable. So inside this closure, we need to set the self.dragging as the board list, and we need to return NSItemProvider passing the board list. And next we also need to add additional element here for the on drop modifier on the board list view, so it can accept the board list type identifier. Now when the user, now this board list view accept two types of model when it's being dropped an item card or board list. Okay, now let's try this. Build and run. Okay, let's begin by dragging this. Okay, and move it here. Nice. As you can see, it is being swapped. Let's move this backlog around. Nice. This is very smooth. Love it. I'm not sure why when we drag this, that button gets like rendered into a black rectangle. That is, I think there is a bug from the SwiftUI. Okay. Okay. We have successfully implemented the board list reordering. I think we have successfully implemented most of the features. But next, I want to also implement some functionality for the board. For example, I want this navigation button here where we can rename this board. So let's just implement that. That will be very quick to implement. So let's go to the board view. Inside the this navigation story, inside this scroll view, let's add additional toolbar. Here I can simply initialize a button and let's give it a name of rename. For the action closure, I want to create a new method, private func handle rename board. Just invoke person or text field, passing rename board as the title. We don't need this. For the default text field text, let's pass board.name. And for the confirm action, let's grab the text parameter. And here, let's just use let text and check where the text is not empty to continue. And here, simply we can assign board.name with the text. And finally, we need to invoke this here, this inside this button rename action closure, invoke handle rename board. Okay, let's build and run. Okay, you can see this rename button being rendered here. Click. Nice, we have this art text field with the current name, Lexia board. Okay, let's just add this, multiply this, and then save. Nice. As you can see, the navigation title containing the board name is updated. Okay, and before I close this, as we already implemented, I think all the features that we want, but there's one more thing that I want to implement, which is to persist the board, So when the user kills the app, we can get the last board state that we have edited. Okay, so to implement this, we need to make the board, this board class, also conform to the codable. Okay, and this board also have two publish properties, so we need to implement the decoding and encoding explicitly by declaring a coding keys with a type of string that implement to the coding key protocol. We will have three cases: ID, name, and list. Okay, and next we need to implement init from the coder Let's grab the container and invoke the coder container kit by coding keys.self. Let's assign the ID with invoking container the code UUID.self for key ID. Next one is name. Try container the code string.self for key name, and self.list is the final property. Try container the code array of BoardList .self as the type, and for the key it will be lists. Okay, next is the encode to encoder. Let's grab the container and put it into var. Invoke encoder container kit by coding keys.self. Let's encode all of the properties by invoking container encode ID for key ID. Make sure to prefix with try container encode name for key name, and finally encode the list property for key list. Okay, let's build. Okay, the build succeeded. Now we should be able to persist this. We should be able to encode this to data and store it in a user document directory. For that, let's create a class. Sorry, I mean a struct. Set the models folder. Okay, or you can create another folder. Maybe you can call that service. And I'm going to give a name of BoardList repository. Okay, here I'm going to just use a struct BoardList repository. It's the name. First, I'm going to declare a private var. This will be computed document directory URL. Actually, I'm going just to name it safe path URL, the type of URL. So here I'm just going to invoke file manager default and URLs for the document directory in user domain mask. This will return an array of URL, but I'm going to only use the first one. Okay, on iOS it will always be the first one. And we have the safe path URL. Now let's create a method load from disk. Sorry, but here I think I forgot to add the appending path component. Let's just give it a name of board.trl or on format extension, and then load from disk. So basically here we need to grab the data using guard let try data with the contents of the safe path URL. Okay, and if it fails we just return, and we can invoke return try optional, initialize a JSON decoder and invoke the code. For the type it will be board.self from the data. That is for the load from this method. Next is save to disk. Just one parameter, the board instance itself. So to save a board, first we need to okay, sorry, I don't think we need the return here. Uh, Sorry, so I think we need to add the return type as optional board here. And for the save to disk, we can simply invoke, sorry, I forgot to also return nil in here. For the save to disk, we can invoke initialize JSON encoder and invoke encode passing the board. And let's put this into guard let data, else we just return. And finally, we can invoke data, make this optional, data save to, this is data, right? Write to, for the URL, it will be save path URL. And let's also pass an options to make this writing atomic. So the data doesn't get corrupted if it fails to write in the middle of the operation. Okay, now let's build. Okay, the build succeeded. So when should we use this? Actually here inside the board view, inside this board initialization here. Here let's just initialize a board disk repository and then invoke load from disk. As this is optional, we need to provide a default value. Let's just provide board.stub as the default value. That will be the initial value when the app is installed also. And when should we save? We can save whenever the board is updated, but I think that will be a waste of resources. So I think the best approach that we can use is just to save when the app goes into the background. To do that, we need to listen to a U application with recent active notification, and to receive a notification from notification center in SwiftUI, we can use on receive modifier, attach a modifier here, and this accept a publisher. And actually, we can use notification center dot shared, sorry, dot default, and we can ask the publisher for here. And for the value itself, we can use UI application dot will resign active notification. This is a notification that posts when the app is no longer active and loses focus. In that case, we are going to save. Okay. And the closure, we can just simply ignore the parameter. And here, let's just initialize the client, sorry, board disk repository and invoke save to disk passing the board. So the cons of this, even though we are not making any changes to the board, but when it goes to the background, it will always save the board. I think that's the trade-off that we have to make, and I think it's okay for this. And let's try this. Okay, so here is the board. Let me move this file storage service to done, move this to in progress. Okay, and now let me kill the app, put the app to the background. It should save the board, kill it, and let's try to run again. Nice. The previous board is safe. As you can see here, the to-do is empty, and the in progress board list contains the stack search and error handling. Okay, and in done we have the file storage service that we previously moved from in progress list. Okay, I think that's all the features that we have implemented in this video. Congratulations for completing this tutorial. We have successfully implemented the Trello Clone App from scratch using SwiftUI. There are still many things that Apple can improve from the current SwiftUI drag and drop API. For example, provide more granular control for dragging using a drag delegate. Fix crash when dropping an item to the empty list with onInsert modifier, and many more. I believe Apple will fix current bugs and improve the API further with improved support of customizability. Don't forget you can download the completed project from the GitHub repository I have provided a description in case you encounter any issue. So, until the next one, keep on being a lifelong learner and see you on the next one. Goodbye.